Okay, hello guys. As promised, we're going to do an example together. So this is example 8.4. It's in your book if you'd like to follow me along. We're going to use the z-test using the critical value method, and then we're going to do another one when we use the p-value method. So we have here a setup. We have a 1-year-old. Average height is 29 inches of both genders. So we take a random sample of 31-year-olds in a large daycare franchise, resulting in the following sample of heights, okay? I'm actually not going to do this by hand. I just put everything into a Google Sheet and I just did the average using that. And they're asking me, can it be concluded that the average height differs from 29 inches at significance level of 0.5%? Okay, so let's begin. Remember, our 5 steps are to state the null. I'll remind you over here that it is to state the null and identify the claim. So before I even begin step 1, one of the things that I tend to do is to check my conditions. So let's look at the conditions for the sample. Step 1, do I have an SRS? Okay, do I have a random sample here? Yes, I do. Fantastic. The second condition that is important is that my sample is less than 1/10 of the population. Now that's sort of a thing that you have to read in between the lines. Over here, they tell me that this is a large daycare franchise, so it's possible that they have more than 300 kids. Okay, and the third condition is that my N is at least 30. Once my N is 30, I'm going to be able to use my normal distribution. Yes, I do. I have exactly 30 kids here, so the distribution is normal due to CLT. Okay, so now I want to go and state, actually, I'm going to leave it here. I would like to state my null. And remember, the null is going to be just the status quo. So my null, or H naught, over here is just going to be that the mean is no different. It's exactly 29 inches. Now my alternative over here says, does it differ? Here is a suspicion. So again, always you're making your statements about the parameter, never the test statistic. Never X bar, always mu. And this is over here is different, okay, not equals. This business of different is going to mean that we're going to have a two-tailed test. Now, they give me also my significance level as 5%, so my alpha is 5%. That means that I'm going to go and split that up into 2 corners of 2.5%, okay? And this is something you have to go and pull out your Z-chart and check what is the value of 0.025. Right, go ahead and figure this out, or pause the video and figure this out. Okay, did you get negative 1.96? And if you're looking on this one, you need to do 2.5 with the 95%, okay, of the non-critical region. That should be over here, and 97.5, that should be 1.96, positive 1.96. These are my critical values. Both of these guys over here, these are my CVs. These are the critical values. Okay, this is where I'm going to reject. All right, if I'm ending up in these, I might be rejecting in these little corners over here on the sides. Okay, so the next step, step 3, is compute the Z statistic. So in order to compute the Z statistic, I would actually need to know what is the sampling distribution of the sample mean of the heights. So I actually would like to know, how does these 30 samples of 31-year-olds would actually distribute. So every time I take a sample, that sample is going to be slightly different. So the sampling distribution is actually going to be centered on the parameter. Oh, you didn't see that. Centered on the parameter. And then the variability is going to be this business over here, the population parameter of the standard deviation divided by the sample size. So here is going to be 2.61 divided by the square root of 30. Go ahead and calculate that. I ended up with 0.476. So I'm just going to round that to 0.448. Okay, now that I have all this business, I can go ahead and I can, oh, this is 29 over here, and can go ahead and compute my test value. Okay, Z test value. And that Z test value, I'll remind you, is the observed. What did we observe? Oh, this is something that we actually have to do an average of all this data. Okay, if you do an average of all that data, you actually end up with X bar being 29.45. Okay, and then the sample error is actually going to be 0.48. Okay, so let's go and put all this bit. So this is the observed, this is the expected, and this is the standard error. Let's put it all together into our Z test value. So 29.45 minus 29, which is just 0.45, divided by 0.48. It all ends up being 0.94. All right, where is this 0.94 falls? Oh, it falls over here, right? Somewhere over here. So it's not in the critical region. It's not outside these critical values. So I am going to fail to reject. And that's my decision. Step 4, reject or fail to reject. And step 5 is simply summarize. So let's look at my question. Can it be concluded that the average height differs from 29 inches at the significance level of 5%? Well, I just got a fail to reject. So no, it doesn't differ. Or the most appropriate way to summarize it is going to be, we do not have significant evidence that it differs. Okay, so I'm failing to reject because I do not have significant evidence. All right, we're going to do a couple more examples in the next few videos. All right, see you in a bit.